Let's do some examples about finding the domains of various kinds of function. And here we have an example, y equals to f of x equals to 1 over 2 plus 5x. This is a quotient function, and we know that for quotient functions we must avoid zeros in the denominator. Okay, avoid 1 over 0. Okay, let us set this quantity which involves x to be 0, just to figure out what numbers should be avoided as the values of x. Okay, so let us suppose 2 plus 5x equals to 0. Okay, and solving this equation will give us a value of x which should be avoided in the domain of this function. Let us subtract negative 2 on both sides. That will give us 5x equals to negative 2, and let us divide this equation by 5, which is simply x equals to negative 2 over 5. So we should avoid this number, negative 2 over 5. So that would be domain of f would be simply all the real numbers without negative 2 over 5. Or this can be written as negative infinity up to negative 2 by 5 union negative 2 by 5 up to infinity. Okay. And also this can be written as all the real numbers except x is not equals to negative 2 over 5. So there are 3 ways to write down the domain of this function. Let's take another example which involves square root function. Root under 2 minus 3x. If we have square root expression, then we must not have negative numbers underneath the square root. That means we want to avoid the imaginary numbers. Okay, so avoid root under negative numbers. Okay, root under negative 1. So for that, this quantity must be greater than or equal to 0. So let us suppose 2 minus 3x is greater than or equal to 0. We need to solve this inequality. Let's do that and find the values of x, and that will give us the domain of this function. Let us subtract 2 from both sides, which will give us negative 2 on the right hand side, and let us divide both sides by negative 3. So that will give us x is less than or equals to 2 over 3. Okay, since we have divided both sides by negative 3, then you can see that whenever we divide or multiply by a negative number, then the sign must be reversed. Okay, so x is less than or equals to 2 over 3. Then domain of this function is simply negative infinity up to 2 over 3. Okay, or in terms of in other words, you can write down in this way. So this should be x is such that x is less than or equals to 2 over 3 in set notation. Now let's take another example, which is a combination of both quotient function and square root function. Okay, y equals to f of x equals to 1 over root under 2 minus x. Then you can clearly see that by the use of quotient function, we know that we must have this denominator must not be equal to 0. Denominator 2 minus x must not be 0. 2 minus x must be greater than or equal to 0. So we know that root under 2 minus x must not be 0 means simply 2 minus x must not be 0. Let us combine this statement and this statement, where 2 minus x is not equal to 0 and 2 minus x is greater than or equal to 0. So that will give us, so combining these two will give us 2 minus x is greater than 0. Okay, since if we have 2 minus x equals to 0, then this quantity will turn out to be an undefined quantity. So we must have this. So let us solve this. Let us subtract 2 from both sides, which will give us x, negative x is greater than negative 2. Divide both sides by negative 1, so that will give us x is less than 2. Thus the domain of this function is simply x is less than 2, means negative infinity up to 2 without this 2, and also it can be written as all x such that x is less than 2. So this is the domain